Trig equations can be really tough because even though you have a limited number of formulas that you'll use during the solving of the equation, and here's the most common ones that you'll use, you're not going to use all of them. You're not even always sure which of them you're going to use. So it does involve a little bit of creativity, and that's where it can become sometimes a little challenging because you may start doing some operations on your equation, and 2 or 3 minutes later you realize you're not really going anywhere useful. So you got to start over. So what I'm going to do is identify some good places to commonly start. And what I usually like to do is focus on these right here. These are the more complicated trig identities. And usually I like to solve the more complicated side of an equation first. I like to start there. And that tends to work better. I'm not going to say it always works better. And sometimes you'll find that you just have to use one of the quotient identities to start off your equation, right? Could happen. But in this case, what we're going to focus on is sine of 2 theta. Okay, I'm pretty sure that's going to be useful for me because I see it right here, sine of 2 theta. And I'm going to turn that into 2 sine theta cos theta equals 2 radical 3 cosine squared theta. Okay, now as soon as I realize I can factor this without using any more trig identities, I'm going to run right to factoring. Okay, I use trig identities when I can't do factoring, like in that first step. But now that I can do factoring here, we don't have any more need of trig identities for the moment. We'll see if we need them later. But this is going to turn into 2 sine theta cos theta minus 2 radical 3 cos squared theta equals 0. Now, I don't know about you, but I'm already getting annoyed by that 2 in there. I'm just going to cross that out if you guys don't mind. So we're just going to have sine cosine minus radical 3 cosine squared. And now factor out that GCF. Okay, this thing has a GCF in it. Not sure if you saw this yet. Take another glance at it. It's the cosine, right? I can take cosine out as a factor. That's the most basic kind of factoring. And what's left behind is sine theta minus radical 3 cosine theta. And the result is equal to 0. Now, if you remember how factoring works, we have to solve each of these separately. So the first thing I'm going to solve is cosine theta equals 0. And that's pretty easy. If you remember your unit circle, right? Where is the cosine equal to 0? Right here and right here, corresponding to the x coordinates where it's equal to 0. So this means theta equals pi over 2 and 3 pi over 2. Those are 2 of my answers. And now we move on to the next one. Let me grab a different color here. So I'm going to take that guy and say, okay, sine of theta minus radical 3 cosine theta equals 0. And sometimes people get stuck with this one in particular. It's a little tricky. You can't factor it. There don't appear to be any of these identities in here. There's certainly not any double angles, right? I don't see any Pythagorean identities of any kind. Nope, those aren't useful. But here's the key. Up here, there's a tangent identity, and I'm going to use that one. Okay, if I just rearrange this a little bit. So I get sine of theta equals radical 3 cosine theta. And now I'm going to divide both sides. So I get sine of theta divided by cosine of theta equals radical 3. Now what's sine of theta over cosine theta? That's tangent theta. So where is tangent of theta equal to radical 3? Remember, there's 2 places on your unit circle. They're both close to the y-axis. So we have 2 more answers here. Theta equals, let's see, that looks like pi over 3. And what's the other one? 4 pi over 3. Okay. So in total, we have 4 answers.